This will be a quick video about creating a simple neural network using PyTorch. I won't go into too much theory, but give you a practical hands-on guide to create neural networks using PyTorch. The notebook that I will be using for this video will be available on GitHub, and you can find the link in the description of this video. The data that I will be using for this video is from a Kaggle competition, and the link is present in the notebook. I will also put in the description box the same link. So let's quickly get started. First, we'll import all the relevant libraries from PyTorch, Pandas, scikit-learn, and so on. The data that we'll be using is in a CSV format. It includes a training dataset as well as a test dataset. First, let's import the training dataset as a Pandas data frame. You can see that this training dataset has 202 columns. The first column is a unique identifier for each row. Second is a target column which has two values, 1 and 0, and then there are 200 independent variables. As you can understand that since the target variable has only zeros and ones, so this is a classification problem that we are dealing with. So the neural network that we'll be creating will be for the purpose of classification. We can run describe function on this data frame, and as you can see, the variables that we have in this data frame are not normalized. They can have any value between -infinity and infinity. So first step that we'll do as part of pre-processing is to normalize our independent variables, because that is useful when we train neural networks. As a first step, what we'll do is we'll find the name of all these independent variable columns. So you can see here var columns has 200 values. So these are the name of all the independent variables that we have. We'll use min-max scaler, which is a function from scikit-learn, to normalize our values between 0 and 1. After normalizing, when we run describe, you can see the values have now been scaled between 0 and 1 for all the independent variables in our dataset. Next, what we'll do is we'll split this data frame into two variables, the x variable and the y variable. When we do it, we'll get NumPy arrays, but for the purpose of training our neural network model using PyTorch, we'll have to convert them into tensors, and these two lines will essentially do that for us. Next, we will split our training data into a training dataset and a validation dataset. 80% of our data will go into training and 20% into validation, which is specified by this variable called test size. And you can see the output shape of the tensors that we have created just now. The next step is to define the model structure or the architecture for our neural network. We'll use sequential class from PyTorch. This model will have three layers: an input layer, output layer, and a hidden layer, which are essentially the three linear layers which are specified here. The input layer has 200 inputs and 80 outputs. The hidden layer has 80 inputs and 10 outputs, and the output layer has one output. For the input layer and the hidden layer, the activation that we use is ReLU, and for the output layer, the activation that we use is Sigmoid. Right? Again, I won't go into the theory of all this. You can refer to a bunch of videos or documentation online to understand what activation functions are and why do we use ReLU and Sigmoid in a particular place. And this can be changed. You can use different activation functions depending upon what suits your use case. We can print the model here and see how the structure looks like. It is exactly what we had described initially. Finally, what we'll do is use our data for training the neural network. For that, we'll need to define a loss function. Here I've used binary cross entropy as the loss, and we'll use an optimizer, which in my case I have used stochastic gradient descent with a learning rate specified here. The training will be done over 20 epochs and will have a batch size of 1000. The training is actually accomplished through these four loops. We have two for loops here. First loops through the 20 epochs that we have, and second loops through our training data according to the batch size that we have specified. In this loop, first what we'll do is we'll split our training data into various batches. So as we loop through the various batches, we'll create X train batch and Y train batch. These batch data can then be used to make predictions. So essentially we'll use X train batch, which is our independent variables from our training data, to predict the Y variable for our training data, right? And that variable is called Y train batch pred. We'll do the same thing for validation data as well. We'll pass xval and get yval predict, which is essentially the predictions from the model that has been trained till now on the validation data. right? Now that we have predictions on both the batch train data as well as the validation data, we'll calculate the loss values for both training data as well as validation data. The final step in this loop is to back propagate and update the bias and weights, essentially all the parameters in our neural network, which is done here, right? Now, one thing what we have done here is to log or essentially append the loss that we get after each epoch into two lists that we have defined initially, one for training loss and another for validation loss, and we are appending this here, and we are also printing the training loss and validation loss after each epoch, which you can see here in the output. It's very apparent that as the model is training, as the number of epochs are increasing, the training loss is reducing, and similarly the validation loss is also reducing. We can visualize this more easily by creating a data frame from the lists that we have, which stored the training loss and validation loss. Using this data frame, I have just plotted the training and validation loss. As you can see, the loss decreased quite substantially during the initial epochs as the model was learning on the training data, but after a certain number of epochs, the reduction in loss actually plateaued and we did not see much change in loss after that, right? So I hope that this whole walkthrough will have provided you a good understanding of how to create a simple neural network using PyTorch. You have a model which is trained now. You can use this to make predictions on an unseen data and get the class labels for that unseen data. And you can also calculate metrics like precision, recall, FN score, AUC score, and all that is normally done on a classification problem, and understand how good your model is. There can be several improvements that can be done on this model, but I won't go into that in this video. As I mentioned, this is a quick hands-on walkthrough. But if you found this video helpful, please press the like button and click on subscribe so that you get notifications in future if I publish any similar quick tutorials. If you have any questions, feel free to put them in the comment section. Thank you for watching.